libère un ou plusieurs électrons. In this case, dans ce cas, in this case, what is a reduction? What is reduction? In this case, it is the opposite phenomenon. C'est le phénomène opposé.
Which caps an electron or more.
It is a chemical reaction, during which a molecule or an atom attracts, attire, or attire an electron or more. Okay? During which, for example, we can say a molecule or atom catches, donc attrape, attire, or gains an electron or more. Okay? La réduction, c'est le phénomène inverse. It is the opposite phenomenon. It is a phenomenon or a chemical reaction during which a molecule or an atom attracts, gains, or catches an electron or more. Okay? If there is no oxidation, no reaction is possible, and no reduction is possible. And if a reduction cannot take place, oxidation cannot take place either. Okay? S'il n'y a pas d'oxydation, la réduction ne peut pas se faire. Les électrons que le composé va capter, il faut qu'il y ait une espèce qui va les libérer. If you want a reduction to take place, si vous voulez que la réduction se produise, if you want reduction to take place, electrons have to be released from an oxidation reaction. Si vous voulez qu'une réduction se produise, il faut qu'il y ait des électrons libérés lors d'une oxydation. And a compound, a molecule or an atom cannot perform an oxidation if there is no compound to catch the electrons. D'un autre côté, on the other hand, s'il n'y a pas un élément ou une molécule qui va capter les électrons, l'oxydation n'est pas possible. OK? Do you understand? Il y a de l'ordre dans la nature, il y a de l'ordre, subhanallah. Mais s'il y a une oxydation et les électrons vont être libérés dans. Non, il n'y a d'oxydation que s'il y a une espèce pour les capter et il y aura donc une réduction à côté. C'est comme les acides et les bases. The same thing exists for acids and bases. There is an acid cannot release its proton if there is not a base to capture it. OK? Un acide ne va jamais libérer son proton s'il n'y a pas une base pour le capter. OK? C'est des couples. Those are couples. Betoul, do you want to add something? Feel free to add something. I can see your hand.
Parfois.
Ah, okay. You didn't
Sorry.
raise your hand. You didn't do it on purpose. Sans faire exprès,
Yeah.
not on purpose. Okay? It hasn't been done on purpose. No problem. Who could tell me what happens to the oxidation number or the oxidation state during an oxidation reaction and during a reduction? What happens to the oxidation number or the oxidation state? Who could tell me? On dit le nombre d'oxydation ou l'état d'oxydation. The same thing in English. Oxidation number or oxidation state.
Yes, ma'am.
Who could tell me what happens?
What happens? I know, mais en français.
You know, but in French. Go ahead. Allez-y, go ahead. We will translate. Allez-y, on va traduire. Go ahead. We will translate.
Tous les éléments du tableau périodique cherchent la stabilité. Et la stabilité, on sait que les éléments du tableau périodique, les gazards sont les éléments les plus stables du tableau périodique parce qu'ayant une couche de valence saturée. Et tel que les éléments cherchent leur stabilité, ils veulent être comme les
The noble gases.
comme
Les gaz rares, noble gases.
comme les gaz rares. Comme les gaz rares, bien sûr,
Noble.
ce qui concerne la couche de valence. Ils cherchent cette stabilité, soit avec une perte des électrons ou avec un gain des électrons. Ça dépend le positionnement et la famille et le groupe de l'élément chimique. On a des
You are
éléments
right.
qui ionisent avec une perte. خلاص. باين نكمل ولا العربية.
No,
Pardon.
no, no, of course, I'm listening. No, 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 I'm listening. Je vous écoute, I'm listening.
J'ai
Go
expliqué le
ahead, allez-y, I'm
principe.
listening.
C'est pas la peine de détailler,
Yes, you
madame.
are right. Actually, you are right. What you said is correct, but what you said is not what I asked. Ce que vous avez dit correct, mais ce n'est pas ce que j'ai demandé. I asked you what happened to the oxidation number of a compound during oxidation, and what happens to the oxidation number of a compound during reduction. Qu'arrive-t-il au nombre d'oxydation d'un composé quand il y a oxydation, et qu'arrive-t-il un élément, pardon, le nombre d'oxydation d'un élément dans un composé durant une oxydation et ce qui arrive durant la réduction. But what you said is correct. All the elements look for more stability, for a higher stability, and it depends on the position, in their position in the periodic table. Sometimes they have to release their electrons to be more stable, and sometimes they have to attract electrons to become more stable. And that difference makes what we call electronegative and electropositive elements. You are right. This is about electronegativity. Are they electronegative or not? If they are electronegative, they would like to attract
C'est le
electrons.
pouvoir oxydant aussi.
And they attract. Yes, exactly.
Et ce qui concerne-
That oxidation ability, you are right. But what about, no, but in this case, dans ce cas, I'm asking you, during an oxidation reaction, an element will
Madam,
lose its
in the case-
C'est la
electrons.
perte de l'électron. C'est
In the case
c'est la
of
perte.
oxidation, there's the number of electrons increase, and the inverse in reduction.
Not the number of electrons, the oxidation number, Batul. Huh?
Okay,
Batul?
the oxidation number, yes. Yeah.
Yes, because the number of electrons will decrease, va diminuer, but the oxidation number will increase. You are right. رقم الأكسدة يزيد. Le nombre d'oxydation, l'état d'oxydation va augmenter during oxidation. But during reduction, the opposite reaction, the oxidation number will decrease. Le nombre d'oxydation va diminuer. OK?
Va réduire.
Et il va
Yes,
diminuer. Yes, it will decrease. Okay? Who could tell me a last information important in this example? What is the oxidation state, or what is the oxidation number of the metals you can find in their solid states?
In
What is
solid
the
state.
oxidation? Yes, the solid state. For example, you take a piece of copper, for example, in your houses at home, you may find a plate made of copper. Vous pouvez trouver une assiette faite de cuivre, for example. It is a solid, it is copper and it is a solid. What is the oxidation number of that copper?
C'est
What is the oxidation?
+2?
c'est le numéro d'oxydation le plus élevé, madame. Le
Plus
plus
two.
courant.
It is actually the oxidation number of copper when it is a solid. It is the oxidation number of aluminium when it is a solid. It is the oxidation number of iron.
+2.
It is always
+2.
the oxidation. The oxidation number. Keep it in your mind. As future chemists, keep it in your mind.
Madam,
The oxidation number. Tell me, Lubna.
I think it's 0, no?
Yes, exactly, Lubna. The oxidation number of all the metals that exist in their solid state, tous les métaux dans leur état métallique, ce qu'on appelle l'état solide, on appelle ça l'état métallique. Okay? The metallic state, the solid state is an oxidation number of 0. Okay? We say, for example, copper 0. We say iron 0, aluminium 0. All the metals that exist in their solid state have an oxidation number of 0. We say in French, l'état métallique, état d'oxydation 0. Okay? This is the solid, in the solid state, c'est l'état solide. But tell me, When you have some copper in solution, quand vous avez du cuivre en solution, or you have iron in solution, or you have many other metals that can exist in solution, les métaux qui peuvent exister en solution. For example, calcium, magnesium, copper, iron, many metals can exist in solution. Beaucoup de métaux peuvent exister en solution. What is their oxidation number?
It dépend du solution, du solvant.
Non, non. It depends on, you are right, ça dépend. Mais de quoi?
Avec qui? Avec
Ça dépend
quoi?
de, pas le solvant, Hudayfa, ça dépend du métal. It depends on the metal. For example, copper, par exemple, le cuivre. Copper can exist as copper 0, copper 1, and copper 2. Hudayfa, it is about what you said previously, what you said earlier. C'est en rapport avec ce que vous avez dit précédemment.
Oui.
It depends on structure, on the stable, configuration. Ça dépend de la configuration la plus stable. Okay? If the most stable configuration, electron configuration, requires to lose 2 electrons, si la configuration la plus stable nécessite de perdre 2 électrons, the metal will lose 2 electrons and it will be an oxidation number of 2. Okay? For example, copper 2. Okay? If the most stable configuration requires to lose a single electron, si maintenant la configuration requiert de perdre un seul électron, it will be copper 1, for example. Copper can exist as copper 1 and copper 2. For example, iron can exist, le fer can exist as iron 2 and iron 3. For example, vanadium has several oxidation states. Vanadium can exist as vanadium 2, vanadium 3, even vanadium 7.
Yeah.
That especially with oxidation state of 1, alkaline earth metals can exist with oxidation states of 2, but the transition metals, which means the metals that belong to the block D, they can have many oxidation numbers, many oxidation states. Okay? Let me summarize. Permettez-moi de résumer quickly. When a metal exists in its solid state, the oxidation number is 0. If you want to have that metal in solution, that metal can exist as, for example, +1, +1, or +2, or sometimes even +3, 4. It depends on the metal. If they belong to the alkali metals, they will have the oxidation state of +1. If they belong to the alkaline earth metal, they will have oxidation state of 2. If they belong to the transition metals, they can have oxidation states going from 0 to even +7. But it depends on the metal. Ça dépend des métaux. Okay? Do you understand?
Yes, Mark.
Do you understand? In this case, I'm talking about iron. This is iron. Iron, when it is a solid, has an oxidation state of 0. When iron undergoes, comme-t-il subit, when iron undergoes oxidation. When iron undergoes oxidation, because of what? Because of the oxygen that exists in the air and because of the moisture, the water molecules that exist also in the air. Le fer va subir, will undergo. Do you remember undergo? We saw that verb at the beginning. On a vu ce verbe au début, subir. When iron undergoes oxidation because of the oxygen or the moisture, à cause de l'oxygène ou à cause de l'humidité, the water that exists in the moisture of the air. Because of these compounds, iron will experience or will undergo oxidation. Its oxidation number is 0, and that oxidation number will become -2 or +2 or +3. Le fer va donc s'oxyder et il va devenir le fer 2 ou le fer 3. OK? Il existe dans ces deux états d'oxydation. It exists in these 2 oxidation states. OK? And because iron is not iron 0 anymore, now it is iron 2 or iron 3, the color will change. La couleur va changer. Sorry. The color will change. La couleur va changer. Il a subi une oxydation et il a formé du fer 2 ou du fer 3. Il existe dans les deux états. OK? Over time, avec le temps, iron develops a red coating called rust. This is an example of an oxidation reaction. Other everyday examples include d'autres exemples du quotidien, everyday, du quotidien, everyday, include formation of verdigris on copper, la formation du verre de gris. In French, we say verre de gris. And in English, it is the same word. We can say verdigris or we can say verdigris. Both are correct, okay? Other everyday examples include formation of verdigris on copper and tarnishing of silver. D'autres exemples du quotidien incluent la formation du verre de gris sur le cuivre et quand l'argent ternit. OK? Quand l'argent ternit, qui يكحل الفضة تكحل. OK? Verdigris, which is a copper, we say verdigris, I said, or we say verdigris. Verdigris, which is a copper compound, green or bluish, vert ou bleuté, is responsable for the Statue of Liberty's famous green color. Verdigris, which is a copper compound, green or bluish. Il est vert ou bleuté. When something is blue, you say it's blue. When something is similar to blue, quand quelque chose est similaire au bleu, proche de la couleur bleue, you don't say it's blue. You say it is bluish. Okay? When something is not green, but it is similar to green, how do you call that? When it is yellow, it is not yellow. It is similar to yellow. How do you say that? When it is not red, but close to red, how do you say that? Guys,
No.
do you hear me?
Yes. Yeah.
You add ish. C'est pas bleu, c'est bleuté. Vous dites bluish. It is not green, it is greenish. It is not red, it is reddish. Reddish, similar or close to the red, the color red. Greenish, it is similar or close to the color green. Okay? You say yellowish, which means it is white, c'est blanc, mais proche du jaune. Yellowish, reddish, yellowish, bluish. Okay? Verdigris, which is a copper compound, it is the result of the oxidation of copper. Verdigris is the result of the oxidation of copper. Okay? Is responsible for the Statue of Liberty famous green color. Do you know the adjective famous?
Yes.
Famous, c'est célèbre. Here is the color of the Statue of Liberty. Tell me, guys, do you know the metal that has been used to build or to make the Statue of Liberty? To craft the Statue of Liberty? What is the metal that has been used? Yes. Who answered?
Maybe iron.
Who gave me this answer? Ayub? Actually, Ayub is right. Je viens de dire, be careful. I just said that if it was iron, the oxidation would give a red color. And copper, with oxidation, gives a green color, a green bluish color. Which means that when you see that it is green, quand vous voyez que c'est vert, vous savez que c'est du cuivre. Parce que le fer donne une couleur rouge. For example, you are at home. No, you're not at home. For example, you are with your mother, your sister, or a friend, and that person wants to buy an object made of copper. Vous êtes avec une personne qui veut acheter une pièce de cuivre, un objet en cuivre. And you are chemistry students. Vous êtes des étudiants de chimie. You take that object and you see some red color. I don't know. You find some red color on it. You find on it some red color. Vous trouvez sur cette pièce de la couleur rouge. You will say, be careful. This is not copper. Attention, ce n'est pas du cuivre. because the red color appears on iron. La couleur rouge apparaît sur le fer. But if you see, you take that object and you see somewhere, vous voyez quelque part, you will see some green color. The green color means that that metal is actually copper, is really copper. Ça signifie que la pièce, réellement, c'est du cuivre. نحاس. Because the oxidation of copper gives us that green bluish color. And the Statue of Liberty over time, avec le temps, the Statue of Liberty became green. It means that it has been built with, or has been made with copper. Ça, elle a été faite avec du cuivre. And actually, yes, it's correct. It has been made with copper. But tell me, guys, the Statue of Liberty is green inside. Do you think that if we take this external surface, this external coating, si on enlève ce revêtement extérieur, if we take off this external surface, cette surface externe, cette couche externe, this external layer or surface, would the color be green or different?
Different.
It would be red.
It would be red, really? If we take this, if we take this coating, si on enlève ce revêtement dû à l'oxydation, if we take this coating due to oxidation,
It will be the color.
it
gives the
would be the color of copper. It will be it is no the usually la plupart du temps
Reddish.
no the most of the time copper is yellow, il est jaune, golden yellow, il est jaune doré. It is golden yellow copper. Okay, actually if we clean the Statue of Liberty it would have the color of copper. If we clean the Statue of Liberty, it would have the color of copper. But they don't want to clean it because now it is famous in green. Ils ne veulent pas la nettoyer parce qu'aujourd'hui, elle est connue pour cette couleur verte. But this color is not the original one. Cette couleur n'est pas l'original. This color is not the original one. It is a result of oxidation. C'est un résultat d'oxydation. Over time, the copper of the statue underwent an oxidation process, and the color became green. Okay?
Yes.
Okay?
Yes, ma'am.
Okay, this is what we call verdigris. You know this coating, vous voyez ce revêtement? On l'appelle verdigris in French, and the same word is used in English, verdigris or verdigris. Okay? Excuse me, could you give me a minute? So,
Yes, ma'am.
less than a minute. Okay. Verdigris, which is a copper compound, green or for the rusting of iron. Iron will rust, will undergo an oxidation. What is the chemical reaction that what I wanted to tell you, yes, now I want to tell you about silver. What happens to silver? Iron becomes red, copper becomes green or bluish. What about silver? الفضة. Oxidation. What happens to silver? الفضة وش يسمى لها maison? What happens to the silver jewelry, for example, you have
Couleur noire.
at home?
Couleur
black
noire.
color.
Yes, we call that
It will
to
be grey.
tarnish. Excuse me? Excuse me? Could you repeat, please? Miss, I couldn't hear you.
The color will go.
So we call that no. If silver turns to a green color, s'il devient vert, silver, l'argent, it means it contains copper. Becomes darker. Il devient plus sombre. يكحل. الفضة تكحل. Look
So
at this
it's
example. This is what happens. It is a mixture, maybe. C'est un mélange. Okay? But the thing that becomes green is copper. نحاس هو اللي يولي خضر. Okay? It is copper that becomes green. If the green color appears, it means that it contains copper. Yes.
green.
Excuse me, gray. Sorry, yes, gray. It becomes actually, it is gray. C'est gris. It becomes dark. Ça devient sombre. It is gray. It becomes dark. Ça devient sombre. Okay? We call it to tarnish. Ternir en français. C'est terne. C'est terne, ça veut dire qu'il n'y a pas de lumière. Ça ne reflète pas la lumière. C'est terne. Okay? It tarnishes. To tarnish, c'est ternir. To tarnish in English. Okay, to tarnish in English means to destroy the luster of a metal or any surface that reflects light. Here are some definitions. Rust, la rouille, what is it? Is the reddish-brown substance that forms on the surface of iron. C'est la substance brune rougeâtre qui se forme sur la surface du fer. A coating is in French un revêtement, un enrobage. To tarnish is to destroy the luster of a metal. C'est détruire le lustre d'un métal, le lustre ou le lustrage d'un métal, or any surface that reflects light, ou d'une quelconque surface qui reflète la lumière. Si vous détruisez le lustre ou le lustrage d'un métal ou d'une surface qui reflète la lumière, elle ne sera plus capable de refléter la lumière. That metal or that surface will not reflect light anymore. It won't be able to reflect light. Elle ne sera plus en mesure de réfléchir la lumière, de refléter la lumière. Ce qui signifie que elle va perdre son lustrage, elle va devenir terne. It will tarnish. It means that the luster has been destroyed. For example, in your houses at home, you can ask a person to make what we call in French un lustrage. Vous pouvez appeler une personne et lui demander de faire ce qu'on appelle un lustrage. Qu'est-ce que c'est le lustrage? What is it in French, le lustrage? Do you have an idea? Did you ever do that at home? In your houses, did you do that, lustrage? You don't know what it is? It is actually that coating that you put on the floor. C'est en fait avec le revêtement que vous mettez sur le sol pour qu'il brille. If you put some special, of course, un revêtement spécial, some special coating on the floor will be able to reflect the light and it will have what we call a luster. Là, le sol va refléter, il va briller, il va refléter la lumière et il va avoir ce qu'on appelle un lustrage. If the luster does not exist, if the luster is destroyed, هذاك le lustrage s'il est détruit par les détergents par exemple, if the luster is destroyed by detergents, you will say the floor has tarnished. Vous allez dire le sol a terni. The floor has tarnished. Okay? Okay, guys? Okay, do you understand the meaning of to tarnish? Do you understand what is a luster and what is to tarnish? Who did not understand? Guys, do you hear me?
Yes, madam.
Yes.
Yes, madam.